Alright, I just pulled off the highway because it just started doing this again, but you can see it going through every system. This is a P0299 code, and once it throws that code, it kind of puts it in limp mode and lights up everything and indicates that you've got problems with basically every system in the vehicle. So I'm going to try to clear the code and then start up again and see if I can get some data and see what's going on. Okay, I'm going to try to clear the fault codes now. Well, let me read them back. Pretty sure I know what they are. So there's a P0299 current and temporary codes for turbocharger underboost problem. Not surprisingly. So I'm going to try to clear them. It'll be a permanent code, so that won't clear. And then read some data stream. And I want to put on there the wastegate position. Wastegate actual lift and target lift. And then I want to put up the boost target and what the actual boost pressure is. Boost pressure, and the upper limit is what this tool reports as the it reports it as upper limit, but it's actually just the target. Okay, now I'm going to start up and take it down the road and see what happens here. Okay, I'm on a smaller road here, but there's a big hill, so I'll see if I can give it a little bit of gas again, see what happens. Let me just jump in here for a second to point out that we're about 5 seconds into this acceleration, and the target boost pressure that the PCM is commanding is 159 kilopascals. But the actual boost pressure is only 128, so it's over 30 kilopascals below the desired pressure. The code setting criteria for a P0299 is if the pressure is 5.9 kPa or more below the target for at least 6 seconds. So we've almost met that criteria already here. Yeah, so I think, you know, the code setting criteria is the 6 seconds and says to drive with a wide open throttle. So I think it's pretty clear if you're driving for 6 seconds at wide open throttle, you'd definitely be setting that code every time. I've been having these P0299 codes whenever the temperature gets above 80 or so, which has only happened up here in New Hampshire maybe 3 times or so, 3 days or so. But due to the nature of the failure where it is boosting but just not getting the full boost pressure, and given the fact that I've got 186,000 miles on it, I strongly suspect that the turbo is just going bad and has to be replaced. But before throwing a new turbocharger in it, because they are pretty expensive, I just wanted to go through the other Honda troubleshooting service data for the P0299 and make sure it's nothing else obvious. So most of you probably know more about how a turbocharger works than I do, but for those that don't, the gist of it is that the exhaust gases come out of the engine, go through the turbocharger, spin up the turbine blade. There is a wastegate, which is a control valve that's controlled by the PCM, so it can be controlled to any value between 0 and 8 millimeters of lift, and the PCM uses that control to determine how much the turbocharger spins up and therefore how much pressure is generated on the intake side. The intake side, the air comes in through the air cleaner and then gets compressed and pressurized by the turbocharger and then goes into the intake manifold. There is a bypass control valve on the intake side, and that opens when you decelerate quickly to provide a secondary path for the air. If you didn't have that, then this air would really slow down as the throttle plate closed, and would slow down the turbo from spinning very quickly. And then when you reaccelerate it, it would take longer for the turbo to spin up again. So the P0299 code is looking at the pressure in the intake manifold when it's operating under boost, and it's basically trying to establish a certain amount of pressure based on the engine loading and other factors. And despite the fact that it's got the wastegate so that all the exhaust is going through the turbine, it's still not able to get the pressure up high enough to the target value. And so what are some things that could cause that? Well, one thing is just if the turbo is going bad, and for example, if the bearing was going and it couldn't spin the turbo up as fast as it wanted to. But there's other factors outside of the turbo. For example, if you had an air leak somewhere in the intake between the turbo and the intake manifold, an air leak here could prevent you from developing boost pressure. So in my case, I've visually inspected all of those components, the piping going down to the intercooler and then back up to the intake manifold, and I haven't seen any issues there, but it didn't smoke it or anything. Another problem could be the wastegate. Although there are a lot of DTCs or error codes just for the wastegate control, and it does have telemetry in it, so it does know how far it's moved. So chances are you'd get some other error codes if it was the wastegate. In addition, the wastegate is an integral part of the turbo, so you can't replace it separately, so you'd still be replacing the turbo if there's a problem with that. If the bypass control valve was stuck open, then again you'd lose boost pressure when you didn't want to. So I think you'd probably lose more boost pressure than we're seeing, and it probably wouldn't just be on hotter days. I think the hotter days is because the air density is lower, so the turbo has to work harder to get the same pressure. But if you did have that bypass control valve open, again, it could prevent you from building up boost pressure. So the bypass control valve is actually, again, a part of the turbocharger. This pathway is all built into the turbocharger, so that would require replacing the turbocharger too. But the bypass control solenoid valve is separate, and we'll be checking to make sure that that's functioning correctly and not erroneously commanding the control valve to be open. In addition, not shown on here is the fact that there are two evap lines coming off the intake. The PCM, both of these have separate solenoid controls, and then they go to the charcoal canister, and the PCM uses them based on the operating conditions to open that solenoid and vent the charcoal, the fumes in the charcoal canister into the intake. But obviously when you're boosting and this has got a lot of pressure in it, that solenoid better be closed, because otherwise it's going to be a huge boost pressure leak. And so we'll double check that solenoid is closing correctly and sealing, and check that this piping has no leaks in it. I just wanted to go through the rest of the Honda checklist here and just see the other obvious things. I'm pretty sure the turbocharger needs to be replaced, but just wanted to make sure I didn't miss anything obvious. So the first one was the air cleaner check. I already looked at that, and that's nice and clean. And then the second is check for the leak through the air intake duct all the way to the throttle body. And I did do that, including like the intercooler and stuff. I didn't smoke it or anything because I don't have a smoke machine, but I did check for any obvious leaks there. And then check the evap canister purge line, so I can show you where that is. Let me move you over a bit. So here's the evap canister purge line, this side, and then this side, and the valve, and you know the hoses all look good. They're complete length, so I don't see any visual problems there. Okay, and then the next check is for the evap canister purge valve itself, so I'll check that next. Okay, so to test the evap purge valve, then with the valve off, which is closed, which is the normal state, then it should hold a vacuum. So I'm just using a little vacuum tester, and you see it holds a vacuum on that side, and then it should hold a vacuum on this side as well, and it does, so that's correct. And now if we maybe if I even put a little vacuum on it, so I can hold that there, And then if I open the valve in test mode, then you can see it dropped to 0. My gauge is just a cheap Amazon gauge and it doesn't read 0, but you can see that now with it open, there is no vacuum. So I'm just using the evap test mode on this launch scan tool. So you can also hear the solenoid click when it goes on and off. Okay, and then I'm going to open it again and check this side too, that it doesn't hold a vacuum. Yep, no vacuum. So the next check is of the bypass control solenoid valve that turns on the bypass valve on the turbo. And so I've disconnected this hose in the back and then disconnected these two hoses that go to the turbocharger. So then the test procedure is that this hose in the front should hold a vacuum if the solenoid's off, which it does, and then with the solenoid on, it should release the vacuum, which it does. And then from the port in the back, it should hold a vacuum if the valve is on. See if I can get a little different fixture there. Okay, and then for the port in the back, it should hold a vacuum if the solenoid is on, and then with the solenoid off, then it should release the vacuum. And again, my gauge is broken, it doesn't go to 0, so that is its 0 value. So the solenoid, bypass control solenoid looks good from those tests. I'm not sure you could see what I was doing there, so just to be clear, the line that's shown with the orange arrow should hold a vacuum if the solenoid is off, and the port in the back shown by the blue arrow should hold a vacuum if the solenoid is on, so they are opposite. I should say you can also hear it clicking. And feel it clicking when turned on and off. Okay, and then the final check here is applying vacuum to the bottom line here that goes to the bypass valve on the actual turbo, making sure it holds vacuum, and you're supposed to hear a little activation click from that valve. Okay, and I did hear a subtle click when it hit about 15. I don't know if you can hear that. Yep, maybe about 13 or so. So I think all of those actually passed the checks. Okay, and then the final check in their checklist is just checking the electric wastegate. And really they're just saying if you activate it in the bidirectional test, do you see the control arm move back and forth? So let's see. Okay, so I definitely saw it retract to the left when it hit off, and it's going to an actual lift of 0 millimeters with a commanded lift of -3.6, but I think it's just railing at the edge. Then when I turn it on, it goes out to 8 millimeter target lift, and it's hunting around a little bit, but it's right near 8 millimeters. So it definitely looks like that has control and is doing the right thing. I will say it is quite noisy. You can hear the pulse width modulation in the motor in there as it hunts around in particular. But it looks like that's doing the right thing, so I think the wastegate control motor is actually behaving properly. So in the interest of full disclosure, I did already take off the intake pipe to the turbo and check the impeller on the intake side and the turbo, and it's got a lot of play in it, so I kind of felt like it was probably the turbo all along, but I wanted to go through those other checks, just make sure there's nothing obvious. So I do have 186,000 miles. I've always done the oil changes when the maintenance monitor came up with synthetic oil, because I know people might be asking about that. But as you know, if you're watching this, probably Hondas do kind of have a reputation for the turbo going at higher mileage, and with 186,000 miles, I guess it's not too surprising. So I'll be replacing the turbocharger today. So the first thing we're going to want to do is start removing some of these intake parts here. Remember, these hose clamps take a 5.5 millimeters, so that's kind of a little bit unusual. Yeah, I guess those turbos do take a beating. I was actually reading a bit about them, and Honda doesn't have too many details, but a lot of them do spin it up to 200,000 RPM, which is pretty crazy in those temperatures and everything. Kind of amazing. I guess they last as long as they do. Pretty amazingly, if you calculate the speed in miles per hour of the edge of the fan, it gets up to like over 1,000 miles per hour, so over the speed of sound. Apparently that is common in turbos. To have the impeller actually spin at supersonic speeds, from what I learned on the internet anyway. But even the air, the intake air going into it can get up to like Mach 0.8 or 0.9 from what I understand, which is pretty amazing. Okay, I think that should all be free. Okay, so that whole unit comes off there. Put the bolts with it so I remember where they go. Okay, we do have to take out the air fuel sensor. The whole catalytic converter has to come out, and then we can get at the turbo here. So I'll be using one of these regular 7/8 oxygen center wrenches. It's disconnected electrically first here. This little clip on the back of this bracket. And obviously be delicate with the wire. You get an extension here. Okay, see if we can break that loose. Guess it looks pretty clean. Probably put a little bit of copper anti-seize on there when we put it back in. Put that up in a safe place. I should say, for all of those solenoid checks and everything, I did do those when the engine was still hot, right after I did the scan data that was showing the malfunction. So at least it was in the same operating condition. I always worry if, like, you know, valves stick in momentarily or something, but I'm pretty sure that's not the case this time anyway. Alright, I'm going to get the coolant bottle out of our way so we're not fighting that the whole time. And you probably know about this filler neck for the windshield washer. Just pops out. Makes it easier to get the coolant bottle out. Okay, I'll set that over there for safekeeping, hopefully. And put this somewhere where I can probably spill it immediately. No, I found a good spot for it. Be a while before I spill it there, hopefully. Okay, then the electrical connector to the wastegate motor can come off. I think it actually is a motor and not a solenoid, by the way. Not that that really matters, but just out of curiosity. And then that harness can, I think, slide off. Yep, there we go. Okay, and then I think I'll take this, the turbo intake pipe off next. Maybe a bigger pair of pliers would help. That's pretty loose because, again, I did have this off the other day. There's a bolt and a nut down on the bottom of this that are a little bit tricky to get to. Let me see if I can get you a shot of that. So hopefully you can see down in there. Let's see, whoa. Okay, there we go. Yeah, so that's the bolt on the one side down on the bottom. If you can see it down there. Right there, and then on the other side there's a motor there. Okay, down there you can see it. That's the nut on the other side. So see if I can get those out and pull that out of there. Okay, those are pretty deep down in there, so probably want to grab a magnet or something and make sure you don't drop them down there. Be a bad start to the project, right? Okay, that's the one side. Let's see if I can get it on the other side. Oh, I think I'm going to have to take off this the bracket, so you can see down in there, hopefully. There's a bracket that holds the two air tubes going to the air bypass solenoid, so we have to remove that first. Oops, sorry. Yep. 10mm, and there's two of them. Oh, of course it doesn't fit in there. And then there's one, oh sorry, I keep knocking into you with my head. Then there's another one down below there. Okay. Okay, one bolt. Okay, and then the other one. And then this whole thing just floats, so I think we can get in there now. Oh yeah. Actually, that bracket's kind of in the way, so I think I'll just take out that bracket first down here for the, oh, you can't quite see it, but there's a bracket down here for the water bottle, and I think I'll just get rid of that and get it out of the way too. Ooh, risky move. Yeah, I don't know whether to be disappointed or not that the turbo went. I mean, it does have 886,000. My 2007 Honda Accord made it to 400,000 without anything major, but it was burning a lot of oil at that point. So I guess not too bad. I haven't had anything major go. I still haven't done the fuel pump recall, gone in for that yet. Always such a pain going into the dealership and having them try to sell you everything. But I haven't had any problems with the fuel pump either. From what I understand, I guess it's a the impeller was improperly manufactured and can swell, and then it gets stuck and won't pump anymore. Fortunately for us, I would say, it's being done as a safety recall, because it could leave you stranded or stuck in the middle of an intersection, I guess. So that's a good thing anyway. They, at least they're footing the bill, so you get a new fuel pump. Oh, come on. Okay, so that's the that's what the bolt on the one side of the intake pipe looks like. And see if I can get the nut out of there without dropping it. That's the trickier one. Not sure how much you can see there, but I think it'll be better once we get this pipe off. Okay, and then there's the nut on the other side. Okay, so that is all loose now and should just be able to come out of there, I think. Okay, maybe I have to remove these hoses first to get a little bit more room. Obviously they're going to have to come off to connect to the new turbo anyway. Feels like I wasn't in here too long ago replacing that water pump. I took that off for that as well, just to get in there, if you watched that video. If only there was a magic tool that just made these hoses just pop off. It's always a bit of a wrestle with them. There we go. Okay, that's that one. Okay, and there's that one. Okay, now this should come out. There we go. And there is a rubber gasket in there, and I will be replacing it as Honda recommends. I'll put a list of all the part numbers that are replaced in the description for you if you're interested. So there is some oil down here on the bottom. You know, I think when these turbos go, because the bearing goes, they can release a bunch of oil into the exhaust or intake and clog up your cat on the exhaust side, so that would be bad. So probably not a bad reason to replace the turbo a little bit early. But I'm not sure if that much is excessive. It's more than I've seen in the past when I had that off for the water pump replacement, I can say that. And you can see there's quite a bit of radial play in this. But again, like, some amount of radial play is acceptable, I understand. Axial play is bad and I don't feel any axial play, but that does look like a lot of play to me. I'll compare the two when we get it, when I get it out, the new and the old. But I think that's probably a sign that it's the problem, but we'll find out for sure. Okay, next I think I'll get this bracket out of the way that holds the air pipe and the harness. Looks like there's one bolt on the bottom of it there. Oops. Okay, now we can remove the heat shield on the top of the turbo. They had Loctite on them, blue Loctite. Okay, and then getting down in this front one a little bit tight. Don't know how hot it's going to be. Oh, it doesn't feel too bad. Nothing worse than watching somebody unscrew a bolt on YouTube, right? I'm trying to fast forward the super boring parts. Hopefully I leave something not fast forwarded. Alright, there's that little heat shield. Okay, now we can see the turbocharger down there finally. Okay, so here you see the wastegate control motor or solenoid, if you want to call it that. And this is the linkage that then goes to the actual wastegate. And so when this opens, it opens a flapper in there that allows the exhaust to bypass the turbine, the exhaust turbine of the turbocharger, and so that makes it not spin as fast. But you can see there's a huge amount of play in this. Definitely a lot more play. I know they're known for play, reading it online, but this actually has a lot more play than the new one, both in the end linkage where it hooks up and each of these linkages. Yeah, a lot of play. But again, it did seem to be tracking the correct wastegate position, so maybe that's not a problem. Okay, next we're going to have to take off this catalytic converter heat shield so we can get at the bolts that fasten the cat onto the turbo. I'm not sure what they make these bolts out of, but it's pretty impressive that they still come out after all that time. So for the downstream O2 sensor, I think I'll just unplug it and hopefully we can just leave it connected right in the cat. When we take the cat out. I might want to just take out this bracket. Okay guys, remind me where that goes when I forget later on how that bracket's oriented. Kind of trying to lay the pieces out in order so they can go back in order and I don't forget anything and have to take stuff apart on the way reassembling it. Okay, I know you can't see there, but this just the heat shield just the very top of the cat. I'm gonna get a. Okay, let's try that. Much better. Okay, and then there's one more in the front here. Okay, is this going to be the one that I drop down in there? Haven't dropped any yet. That's a pretty good start. Okay, we're close, we're close. Okay, there it is. Okay, put those. So yeah, there's just one bolt on top and then two down the sides that are a little bit tight to get to. Okay, next I think, let's see, we've got two coolant lines and two oil lines going to the turbo. For the coolant lines, technically you're supposed to drain the coolant. I'm going to try to clamp them off. It looks like I can clamp this one off up here and not have too much coolant come out. And then the bottom one there goes in, let's see, yeah, right underneath. So I think I can clamp that one off too, and hopefully not have to drain the coolant since the coolant's pretty new in there. Okay, hopefully that's a better angle, so I know it can be disorienting to know where you are now, but here's the catalytic converter and the turbocharger. So I'm just going to see if we can pop those nuts loose. Not sure if they'll need a little bit of heat or not. Definitely don't want to go too crazy if they're I think I'm going to hit those with a little bit of heat. So what do they say in the Northeast? The most important tool is the red wrench, or in other words, the torch. And I just use a MAP gas plumber's torch, and it seems to work pretty well for me most of the time. Just make sure there's nothing that I'm going to melt or anything. It wasn't much, but I don't know how much it'll take. More than that, apparently. Oh, the whole stud's coming out, but that's okay. Alright, how about this one in the front here? Yeah, that's a bolt, and that feels pretty mean too. Not too worried about heating it up the turbo a lot because we're going to be replacing it anyway. Probably too delicate on it, but I'd rather take my time and not snap them off because that's always a real pain. Okay, it's moving and I can see the back end moving too, so that's good. Okay, 2 out of 4 here. So I don't think you can see this one, but it's down in the front here. That one doesn't seem too bad. Let's see, is it? There's 2 of them that are bolts, and then 2 that are nuts. Okay, it looks like that one's coming out with the stud too. And so that's fine. I've got new bolts, or actually new nuts rather. The bolts, it doesn't say anything about replacing, but the 2 nuts that hold it on are supposed to be replaced. Okay, and then just one more bolt in the back. See how that one feels. Yeah, I'm going to hit that one with a little bit of heat too, I think. So I'm darn sure there's nothing under there that I'm going to bother. See what that did. Still feels pretty tight to me. See if I can get to the back of it. I think what I'm going to do is take off that bracket down there, and then I think I'll be able to get to the back side and put some more heat right on the threads in the back. Okay, this is another bracket. You got to remind me where it goes. So I think with that out of there, then I can get the torch in on the back side. I think. Yeah, just let me make sure there's nothing down there. Yeah, I don't see anything down there, so. Yeah, and as always, if you have other ideas on how you'd get it out or whatever, definitely all ears. I'd love to hear. Always nice to be able to trade ideas on things like that. Okay, there we go. Final one. And it did not break off. In case you're wondering, it is free on the other side. Okay, and like I said, the two nuts there are supposed to be replaced if you're into that. And the two bolts apparently can be reused. The gasket there should be replaced, and I'll replace that and the gasket up here. You'll be shocked to know how much those cost. It's like $50 or something like that for the gasket. If anybody knows why, I'd love to hear an explanation. I'm sure it's out of some crazy exotic material, but still. I was originally thinking I'd have to get these bolts, these nuts rather, off of the studs, but I'm sure the new turbo comes with studs, and I have new nuts, so I think we're good to go. Doesn't even matter that the whole stud came out. Actually, it probably just makes it even easier to do the installation. Okay, and that stud came out too. I should say a shout out to my nephews and nieces if they're watching, and all my brothers. I actually have 5 brothers. Sometimes they even tune in. Sometimes they're my only viewers. So hi guys, if you're watching. Probably want to see what kind of trouble I'm going to get myself in this time, right? I think I'll just make sure I can free up those bolts that mount the turbo to the engine now. I won't take them out because I don't want it to fall down. I'm going to have to go down on the bottom and remove the bolts on the bottom of the catalytic converter, and then we'll have to get the hoses off before we get too crazy. And there's 2 oil lines. There's one oil line up here, high pressure feed, and then there's an oil line on the bottom of that too. But for now, I think I'll just make sure I can get those nuts and bolts freed up. And same deal on those. The 2 nuts are supposed to be replaced, per the Honda service information anyway. And the bolts, it doesn't say anything about, so I'll be reusing those. And like I said, this gasket here is going to get replaced. Well, that's kind of nice and free. Oh, it looks like maybe these studs are coming out too. It's probably okay. I'll just have to free those up and oh, no, I guess not. Okay, let's see about those ones on the bottom. Okay, I have some of these pretty decent crow's feet that kind of wrap around it, and I'm going to give that a try to begin with, see how tight they are. Okay, that seemed to do it. I'm not going to lie, I was a little bit nervous about that. I really don't have some really super long handled wrenches, but that would probably be a good thing for me to invest in. Let me get this bracket for that coolant line out of the way first. Okay, let's see if we can get this last one, and then I think we should be in pretty good shape. Oh, I guess you can't even see it, maybe. Or maybe that's better. Okay, yeah, that's not, these weren't too bad. Definitely makes a difference. I guess it's just the amount of heat, but the ones on the Cat are always just like, you know, all the exhaust ones, just super hard to get off. Okay, and then I'm going to leave those in there for now, just to hold it in place until I get the bottom of the Cat undone. Of course, the other big difference is that these bolts are into aluminum too, so that's a lot different than if they're into the you know, steel of the turbocharger body. Okay, so now for probably your least favorite part of the job, unless you have a nice lift in your garage, unlike me. We are up on jack stands here, and I'm underneath the vehicle, and I'm going to remove the bottom of the bolts on the bottom of the Cat. I did free all these up a couple days ago in preparation for this job, so I'll show you some of that I'll show some of that footage of freeing them up in case you're interested, because they can be a bugger to get out. Mainly just heating them up and taking your time, but they should come out pretty easy today, I'm expecting, because they were just freed up. And these are the crustiest, so you could just leave those in and take the brackets off. But I did want to replace them, so I got replacements for those. In addition, you are supposed to replace the nuts that join them together. Maybe before I go too crazy on that, I'll get the other sides freed up, since that feels like it's getting really loose. Probably would have been better if I left those tight and got those nuts out first, huh? Let me just tighten these back up here. With 186,000 miles, I just don't want to put too much stress on that flex connector. So tighten those back up so it doesn't move a lot, and then free these back up. And I did get a new gasket for in here as well. Okay, and then there's one up in the back, which I can't see, and probably you can't see either. Oh, there it is. Okay, this is the last one, so that's all free. Okay, and I think it will help if I loosen up these brackets as well. Just make those swing out freely out of the way, and then make it easier to wrangle this up, because the Cat sits on the bottom of those, and I was planning to take out the Cat from the top. Figure then I'll just leave those in loosely, and then I can just rotate these maybe up and out of the way. That's my thought anyway. Okay, and then I'm just going to let that rest on there. And hopefully I can just pull it up out of the top. I just want to take a picture of the alignment of that gasket there. Make sure I get that back in the right orientation and everything. I think the service data has shows how it goes, but oh, interesting. It's like 3 separate pieces. Huh. Interesting. Okay, now I should be able to just pull that cat out of there. I'm going to be really careful with this oxygen sensor line. Will it fit? Will it fit? It's definitely a tight fit, but it does make it out of there. And obviously treat this thing with a lot of respect, because this thing is like really expensive. Well, it's getting pretty late here, so I'm gonna call it a night and then finish this up in the morning. I guess I can give you a little tour of what it looks like now. So if we maybe I can look in here. So that's looking in the exhaust side of the turbo, and you can see this is the wastegate, which feels pretty loose to me, but again that opens up a little valve there and lets the exhaust bypass the turbine, and the turbine feels actually about the same as the other side. So then tomorrow I think we'll just have to remove the 2 coolant lines, the 2 oil lines. I think that's about it. Oh, the 2 vacuum lines over here. And then the turbo will come out and we'll be ready to put the new turbo in. So I think we've made good progress. Oh, and there's an air hose down on the bottom. So the air comes in through that plastic pipe that we had here into the turbo, and then it goes out the bottom of the turbo and then down into the intercooler down that pipe down the bottom, you can see there. So I'm down at the bottom of the vehicle, and I'd like to just make sure I can free up these bolts and get the bottom of the cat freed up ahead of time, and I'll just put them back in loosely for now. There's 2 bolts here I'd like to remove just because they're getting really rusty and like to replace them, but if those prove too hard to get out, I'll just take out the ones on the other side of the bracket, which don't look bad at all. Probably a smarter guy would just go for those and forget about these, but I'd like to replace them if possible. But you can see they are pretty crusty, so see how that goes. And then there's 3 nuts over here that I have to remove to separate the cat from the flex pipe connector, so we'll see how it goes. I'm just going to get in there with a brush and take some of the rust off of those 2 to begin with, and maybe use the Dremel a bit. So these bolts where the thread comes through and is exposed, if you don't clean the rust off of those well, then even if you manage to free it up, it'll just get bound up as you start pulling it out. So I like to try to get some of the rust off if possible. Start by just giving it a little bit of heat just with a regular plumber's MAP gas torch. Alright, let's see if I can break it loose at all. I definitely don't want to force it, so I'm going to give it a little bit more heat here. See if that did anything. hey, it looks like it's moving, and the threads are actually moving with it, so that's good. So the big thing, once you've got it moving a little bit like that, is to not overdo it and not get too crazy cranking it off, because you can snap it off once it gets partway through. I've learned from experience, so it helps to kind of take your time and go back and forth a little bit and clean up the threads a little bit at a time. Okay, there we go. Not too bad considering how rusty it was.